Good morning, everyone. Welcome to Tech Tips. Today, we are going to talk about connection pooling in multi-tenant microservices, right? The connection pooling in multi-tenant microservices has always been a challenge. So, here, let me take an example without multi-tenancy, and then I'll dive deep into a system where we have to implement multi-tenancy in a microservices. Okay. So, for this scenario, let's assume that the application is deployed on AWS, right? So I have users which makes request to the API gateway to the microservices, right? For example, for the sample sake, I've taken Java Spring Boot microservice deployed in AWS Lambda. It can be deployed anywhere in an EC2 cluster or in an EKS, Kubernetes, or whatever you like, right? There's no limitations. This is just for example, right? So you have a microservice which is in Java, which is connected to a database. So whenever we spin up instantiate a Spring Boot microservice, right? So we have to set up the default connections, right? So here, right, we set the default connections as 5 in our example, right? If that in a typical AWS RDS or database or any databases, right, there will be a limit on the max number of connections, right? Let's assume that the max number of connections is 5. In this particular example, say we have like 10 tenants or 10 clients, right? There is no differentiation between the tenants. Each of the request will pass through API gateway, come to the microservice, and the data gets stored on the same database. All the CRUD operations are on the same database and data is stored on a single database. So we have a single connection. So initially it starts with 5 and based on the load, it keeps increasing, right? That's how it works. This is very simple architecture. There's no multi-tenancy over here. This is a single tenant architecture. Now let's look at the challenges and go to a multi-tenant system. So in this multi-tenant system, so I've made a slight change. Here, the data, as you can see in the diagram, right, it is uh, segregated in multiple databases, right? In most of the secure systems, right, especially in all this healthcare, finance, and other domain. In fact, in any domain, right, these days the clients uh, wants to ensure that the data is isolated, right? So here in this example, the data is isolated in different database for each of the tenants, right? The same Spring Boot microservice, it receives the request. When it receives the request, right, so the request basically will have a token, and or the request header will have a tenant ID associated with it. So this, with this tenant ID, the microservice identified the corresponding database which it has to connect to, and then connects to the corresponding database, right? So it looks very simple. Let me talk about the challenge over here, right? So in this diagram, right, we are showing like three databases, right? Each of the databases will assume that there are like 5 default connections, right? And it's like, so in this example, 15 connections are already associated with this single um, Spring Boot microservice itself. So usually when we talk about enterprise database, enterprise RDS server or an any database instance, right? There will be multiple databases over there, right? It may not be just serving one microservice, right? It will be serving multiple microservices. So let's assume this scenario, right? So we have like 15 clients. So each by default we give them like 5 connections each. That makes it like 75 connections, right? So it's like it is like too many number of connections. So you might ask me why I have to default 5 connections per database, right? The challenge if I don't assign the connections is it will have to create that initial connections at runtime, and it actually slows up the process. That is the reason why we have to default the number of connect in any service, right? Whether it is Java, Node.js, .NET, or wherever, right? We need to initialize, set up the initial connection pools, right? So that's where it comes in. So now, even though these 5 connections are associated with these systems, right? So there is no, it's not necessary that tenant one is always using like minimum needs 5 connections, right? It might just need one. and maybe a tenant one might be like a very busy customer, a large customer enterprise, and it might need by default like more connections as well, right? So and the new tenants will keep coming to the systems, right? We don't have a control on that because we won't be able to dynamically configure that, right? Whenever a new tenant comes in, we might have to allocate some level of connections to them, right? Unless we manage all these connections internally by default by setting up tracking all these connections uh, and whenever the connection and then dynamically manage all these connections, write the complex code to manage these connections, then we don't need to basically worry about this problem, right? Otherwise we have to always manage worry about this connection pooling problem in a multi-tenant database systems like this, right? Hope you have understood the gist of the problem. And how do we understood that? The simple solution might be, so uh, in any service, right, even the Java microservice, right, we can have a hook, tenant identification hook or something on our pipeline when the request hits the controller, right? And then there we identify which tenant it is, and based on the tenant we dynamically allocate connections and things like that. We'll be able to do that. So I'm not saying it's not doable. It is, but it is like managing this connection is very complex, and it can slow down the process as well, right? Because now you have another layer between the request and the database where where we have to do some kind of processing. So in a real-time web applications, right? The APIs are supposed to perform like in 1 seconds and things like that, and it would be very tough to meet such performance if you start doing all this additional checks and balances, right? So how do we solve that? So AWS has seen this problem and solved in a very clean way. So using something called AWS RDS proxy. So here so if you look at this diagram, right, you can see only one change over here between our microservice and the database. There is something called RDS proxy. Basically, the system connects to RDS proxy, and this RDS proxy manages all these connections for us. So we don't need to really manage the connections, right? That is the beauty of it. So the RDS proxy uses this secrets manager in AWS to store this the the details of the connections, right? Basically the username, password, and things like that, right? So for each of the tenant, basically based on the usernames, right, it based on the request, based on the tenant, it will be able to go to the secrets manager, pick the corresponding connections, and come back and connect to the database, right? So, and the performance is really good as well. So that's where the advantages RDS proxy, right? So we had a problem with managing connections. If we ourselves are solving it, I'm not again not saying that it is not it's not something which is not solvable, but it's a very complex problem to manage the connections. We delegate to something like RDS proxy, and RDS proxy manages for us, and our connection pooling problem is solved. And this can be applicable to any microservice, as I was saying earlier, whether it's on AWS Lambda or EKS or EC2, wherever it's hosted. Okay, so that's all for today. Thank you for tuning in. See you soon. Bye.